Hey guys, it is 2A, relationship between force and acceleration. So they say Carlos and Dominique collect the following data from an experiment where they exerted the same force, that's important, same force, we'll call it F, to identical sized boxes with different masses, and recorded the following here. So they got different accelerations here. So here's our masses here for each trial, and here's our acceleration. The first thing they want you to do is to plot these. I went ahead and did that so you wouldn't have to watch me plot these points here. So the green dots here represent the different data points that they gave us. And I went ahead and kind of traced a line along the path that we saw there. So in class, we haven't really seen a line like this, except for on our little intro to different types of lines. So the next part, they actually remind us of the different types of lines here. They say, and I left one of them out here, I couldn't fit it, the square root one there. So which one of these looks like what we just saw there? Well, clearly it's this one right here. So as x increases, y decreases. That's when y is inversely proportional to x here. So if we look on this graph, that's definitely what we got. As mass increases, what's on our x value, our y value decreases, acceleration. So let's put that into words here, right here. It says as mass increases, then acceleration decreases. Therefore, acceleration is inversely proportional to mass. So in other words, as the mass goes up, the acceleration goes down there. So it says on part C, based on your analysis from part B, what could be graphed instead of mass and acceleration that would lead to a linear relationship? Well, if we come back to our line here, basically an inverse proportion looks like this. Y is proportional to 1 over x. We want it to look like a line. We want it to be y equals mx. So we have to change this so it fits in here. So what would we do on our graph right here? Instead of putting mass on this side, we would put 1 over the mass. Because then when we look at it, if we think of 1 over x as its own thing, and we could just call that our new x-axis, then it will fit the equation of a line there. So what is the physical meaning of the slope with the linearized graph in part C? So in order to answer that, you really need to know Newton's second law here. Newton's second law says that force is equal to mass times acceleration. Or if we sort of rearrange it here, acceleration is equal to force over mass. Let me write this one more way here. Let's write it as acceleration is equal to force times 1 over mass. And now we can see, if we make this a line, what everything becomes. The acceleration is our y, so we'd put that on our y-axis. 1 over m is our x there, which leads force there to be our slope. So the force would be the slope in that case.